Hello friends, now in this video we will see some basic concept before exercise 1.1. I will explain it and then we will solve the exercise 1.1. I will explain in a very simple language so that you can understand it. Now the introduction. In mathematics, we frequently come across simple equations to be solved. For example, x plus 2 is equals to 13. If I solve this equation, then what I will get, if I shift the 2 to the right hand side, it has a plus sign and that will become minus. And therefore, here you will get 13 minus 2, that is equals to 11. Now this x is equals to 11 is in the solution of this equation and it is a natural number, that is a n is equals to 1, 2, 3 up to the infinity. On the other hand, if I solve the equation x plus 5 is equals to 5 and if I shift this 5 to the right hand side, it will become minus x minus 5 and that's equals to 0. The solution gives the whole number. If we consider only the natural number, then the equation 2 cannot be solved. Therefore, to solve equations like 2, we add the number 0 to the collection of natural numbers and obtain the whole number. And therefore, the whole number set have the elements 0, 1, 2, 3, 4, 5 up to the infinity. Again, now even if I consider the equation x plus 18 is equals to 5 and if I solve this equation, then what I will get, if I shift this 18 to the right hand side, then I will get here, that is x is equals to 5 minus 18 and therefore it is a minus 13. Now minus 13 is not the element of set of whole number and that's why we consider the another set, that is a set of integers which contains the element 0, 1, 2, 3 up to infinity and minus 1, minus 2, minus 3 up to the minus infinity. Okay, and therefore this is the set of the integers. Okay. One may think that we have enough numbers to solve all simple equations with available list of integers. If I consider the equation like this, that is that 2x is equals to 3, then what I will get here, if I divide on both sides by 2, then I will get here 3 by 2. But the 3 by 2 is not the member of set of integers. Okay. Therefore, we need the number 3 by 2 to solve the equation 4. And if I want to solve this equation, divide the 5 on both sides. First of all, shift the 7 to the right hand side. Then here you will get, that is the 5x is equals to minus 7 divided by 5. And here you will get minus 7 by 5. And therefore, we need the number 3 by 2 to solve the equation 4 minus 7 by 5 to solve the equation 5. This leads to the collection of rational numbers. Okay. The rational number includes all integers plus any number which can be written as a fraction. We have already seen basic operation on rational numbers. We now try to explore some properties of operations on different types of number seen so far. Properties of rational numbers. The closure property. What is meant by the closure property? If we take the two numbers from two numbers and if we add it and they are in particular set again, then that property holds for that particular set. Okay, see this here. The whole number. In the whole numbers, what are the elements? 0, 1, 2, 3 up to the infinity. Now see this table. The operation first is addition, then the number and the remark. if you take the any two numbers from the set of whole number, and if we add that to, suppose I take 0 and 5. 0 plus 5 is a 5. 5 is again a whole number. If I take 4 and 7, 4 plus 7 is 11. It is a whole number. Yes, it is a whole number. And therefore, I can say that in general, a plus b is a whole number for any two whole numbers a and b. And then what is my remark? My remark is that whole numbers are closed under addition. Okay. Now the subtraction. If I take any two elements from the whole number and subtract like this, 5 minus 7, then I will get minus 2. But the minus 2 is not whole number. Then what is my remark? Whole numbers are not closed under subtraction. Okay. If I take the any two elements and see the operation multiplication. 0 into 3, that is 0, it is a whole number. 3 into 7, it is a 21, it is again the whole number. Okay. In general, if a and b are any two whole numbers, then their product AB is a whole number. Then what is my remark? What is my conclusion? Whole numbers are closed under multiplication. It means if you take any two numbers from the whole number and if you take their operation as a multiplication and their product is again in the whole number, and that's why we say that the whole numbers are closed under multiplication. Okay. Now next, division. If I take any two numbers from the whole number and I had taken the number 5 and 8, 5 upon 8, then I will get 5 upon 8. But this is not the whole number because the whole number has the elements like this. Okay. Therefore, the whole numbers are not closed under division. Means the 5 by 8 is not the element of the whole number, and that's why we say that the whole numbers are not closed under division. Now we'll take the set of integers. Z is equals to minus dash dash minus up from the infinity to this minus 3 minus 2 minus 1 and 0 1 2 3 up to the infinity. Now let us now recall the operations under which integers are closed. Okay. Now first operation, addition. If we take any two numbers from this set of integers, if I take minus 6 plus 5, then you will get minus 1. Yes, it is an integer. Minus 5 plus minus 7, it's a minus 12. Okay, and again it is an integer. 8 plus 5, okay, and that is 13. It is also integer. Therefore, in general, a plus b is an integer for any two integers a and b. And therefore, what is my remark and conclusion? That the integers are closed under addition. It means that if we take any two numbers from the set of integers and if we add it, then that element is also in the set of integers. Okay. And then we say that the integers are closed under the addition. Subtraction. 7 minus 5, that is equals to 2. This is an integer. But what about the 5 minus 7, and that's equals to minus 2. It's also integer. Minus 6 minus 8, that is equals to minus 14. It's integer. Minus 6 minus in bracket minus 8. If we solve this, that is a minus 6. This minus and minus, that will become plus. That is minus 6 plus 8, and that's equals to 2. This is also an integer. Okay. Therefore, in general, for any two integers a and b, a minus b is again integer. Okay. And b minus a is also an integer. Therefore, we say that the integers are closed under subtraction. Now the next, multiplication. If I take any two elements from the set of integer, if I take 5 and 8, 5 into 8, that is equals to 40. This is an integer. Minus 5 into 8, that is equals to minus 40. This is also an integer. Minus 5 into minus 8, minus minus multiplication plus, this is also an integer. Therefore, in general, for any two integers a and b, A into B is also an integer. Therefore, integers are closed under multiplication. Now the next, division. If I take again 5 and 8 and 5 by 8, 5 divided by 8, that is equals to 5 by 8. This is not integer because in the set of integers these are elements. Therefore 5 by 8, this fraction is not there. Therefore integers are not closed under division. Okay. Now see this here. You have seen that the whole numbers are closed under addition, multiplication, but not under subtraction and division. However, integers are closed under addition, subtraction, multiplication, but not division. Okay. Now the set of rational number. See this here. First of all, this is natural number. Then the next is a integer, rational number. Okay. Now see this here. We'll see the set of rational number. Okay. Recall that a number which can be written in the form P upon Q, where P and Q are the integers and Q is not equals to 0, then that type of number is called the rational number. Okay. For example, minus 2 by 3, 6 by 7, 9 by minus 5 are all rational numbers. Since the numbers 0, minus 2, 4 can be written as in this form, that is a P upon Q. For example, this 0 can be written as, that is a 0 upon 1. Minus 2 also can be written as minus 2 upon 1. And 4 can be written as 4 upon 1. And therefore they are also rational numbers. You know how to add the two rational numbers. Let us add a few pairs. That is 3 by 8 plus minus 5 by 7. If you add it, then here cross multiplication, then you will get minus 19 upon 56. Okay. Minus 3 by 8 plus minus 4 by 5. If you add it with the cross multiplication, you will get minus 47 by 40. Yes. Is it a rational number? Yes, it is a rational number. Okay. Again, this type of the addition, this is the addition of the two rational number is again rational number. We find that the sum of two rational number is again a rational number. We say that the rational numbers are closed under addition, and therefore we say that for any two rational numbers a and b, a plus b is also a rational number. Next, will the difference of two rational number is again a rational number? See this here, minus 5 by 7 minus 2 by 3, and if you take the cross multiplication, then you will get minus 29 upon 21. This is a rational number. 5 by 8 minus 4 by 5. Their subtraction is again a rational number. And therefore, it is again a rational number. Therefore, we say that all these subtraction is a rational number. Yes, their subtraction is a rational number. And therefore, we will conclude like this. That is, we find that the rational numbers are closed under subtraction. And that is, for any two rational numbers a and b, a minus b is also a rational number. Now next, let us now see the product of two rational numbers. Now we'll see the product of two rational numbers. Minus 2 by 3 into 4 by 5, and their product is a minus 2. We cannot simplify this, therefore we will multiply this numerator upon denominator. Minus 2 into 4, minus 8, 3 into 5, 15. Their product is a rational number. Now again, product of these two, that is a 3 by 7 into 2 by 5 is 6 by 35 is again a rational number. Yes. Minus 4 by 5 into minus 6 by 11, minus minus that become plus 24 upon 55, that is also a rational number. Therefore, product of rational number is again a rational number. That is, we say that the rational numbers are closed under multiplication. That is, for any two rational numbers A and B, A into B is also a rational number. Next we see the division. Minus 5 by 3 divided by 2 by 5, and therefore we can write a minus 5 by 3. This will become multiplied and reciprocal. That is, the reciprocal of this is 2 by 5 is a 5 by 2, and it's a multiplication sign. If we take their multiplication, minus 25 by 6, it's a rational number. That's the division of two rational numbers. Again, 2 by 7 divided by 5 by 3. 2 by 7 into 3 by 5. Then you will get 6 by 35 is again a rational number. Yes, it is a rational number. Minus 3 by 8 divided by minus 2 by 9. Minus 3 by 8 into 9 by minus 2. Minus minus become plus. That is a 27 by 16 is also a rational number. Yes. Now, can you say that the rational numbers are closed under division? Now, see this here. We find that for any rational number, a upon 0 is not defined, because any number which is not equals to 0 and upon 0, this is not defined. Therefore, we say that, however, if we exclude 0, then the collection of all other rational numbers are closed under the division if we exclude it. Okay. Now try this table also. You can try the numbers, rational numbers, integers, whole number, natural number. They are closed under the addition. It means that if we take any two elements from all these sets, add it, then it is again a rational number. It is closed under this operation. What about the subtraction? In subtraction, if we take any two numbers from the rational number, if we subtract it, it's again rational number. Subtract integers, it's again an integer. Subtract whole number, it is not the integer. Natural number does not hold the property of subtraction. Okay, it is not the closed under the subtraction. Next, multiplication. This property holds for all these numbers. That is, the rational numbers are closed under the multiplication. Integers are closed under multiplication. Whole numbers are closed under multiplication. Natural numbers are closed under multiplication. What about the division? Now, the division is not closed, okay, for all these numbers. Rational numbers are not closed under the division. Integers are not closed under the division. Whole numbers are not closed under division, and natural numbers also not closed under the division. It means that if you take any two numbers from this set and if you take their division, and whatever that answer, that element is not belongs to this set, and that's why we say that all these numbers are not closed under division. Okay. Next property, commutative. The whole numbers. Now next we'll see the property commutative for the whole numbers. Okay. First, the operation addition. If we take the numbers 0 and 7, 0 plus 7, and that's equals to 7 plus 0, and that is a 7. 2 plus 3, that is equals to 3 plus 2, it's again 5. Okay, both times 2 plus 3 is 5, 3 plus 2 is 5. Therefore, we say that for any two whole numbers a and b, a plus b is equals to b plus a, and therefore we'll say that the addition is a commutative for the whole number. Now what about the subtraction? If we take any two elements from the whole number, for example 3 and 5, 3 minus 5 is minus 2, but 5 minus 3 is 2. They are not equal, and therefore we say that the subtraction is not commutative. Okay, that is, here a minus b is not equals to b minus a. Multiplication, 3 into 4 is equals to 12, 4 into 3 is also 12, and therefore multiplication is a commutative. What about the division? 3 by 5 is not equals to 5 by 3, and here you will have a into B, that is equals to B into A. And what about here? A upon B is not equals to B upon A, and here we say that the division is not the commutative. Okay, now for the integers. Okay, the operations, numbers. Okay, addition. If we take any two numbers, that is a 4 plus 5 and 5 plus 4, and that's equals to 9. Therefore we will say that addition is a commutative. What about the subtraction? 5 minus in bracket minus 3. Then here, if we solve this, that is this 5 minus in bracket minus 3, minus minus, that will become plus. 5 plus 3, that is 8. Minus 3 minus 5, that is equals to minus 8. Now these two are not equal, and therefore subtraction is not commutative for the set of integers. Multiplication. 4 into 5 and 5 into 4, they are equal, and therefore multiplication is a commutative for the set of integers. Next, division. Again, A upon B. Here A upon B is not equals to B upon A, and therefore we say that the division is not commutative. Now we'll see the set of rational numbers. If we take any two numbers from the set of rational number, and if we add minus 2 by 3 plus 5 by 7, then you will get 1 upon 27. 5 by 7 plus minus in bracket 2 by 3, that is equals to 1 upon 21. And next numbers are also minus 2 by 3 plus 5 by 7, that's equals to 5 by 7 plus minus 2 by 3. Okay, and if we solve this, and then we will conclude that we say that the addition is a commutative for rational numbers. That is, if we take any two numbers from the set of rational number, and if we add like this, first of all A plus B, then you will get also the same number, that is a B plus A. Therefore addition is a commutative for the set of rational number. What about the subtraction? That is is 2 by 3 minus 4 by 5, they are equal. Now we'll solve this. First of all, 2 by 3 minus 5 by 4. We solve this, make the cross multiplication. 4 into 2, you will get 8. 3 into 5, you get 15, minus in between them. 3 into 4, that is a 12. Okay, 8 minus 15 minus 7 upon 12. What about the next number? 5 by 4, okay, minus 2 by 3. Again the cross multiplication, you will get here 15 minus 8 upon 3 into 4, 12. Here you will get 7 upon 12. Now these two are not equal. Therefore we will say that the subtraction is not commutative for the integers, and the integers are also the rational numbers, and therefore we will conclude that the subtraction will not be commutative for the rational numbers too. Okay, the multiplication. It's clear that the multiplication of the minus 7 by 3 into 6 by 5, that is equals to minus 42 upon 50. The same multiplication will be here, that is a 6 by 5 into minus 7 by 3. Their multiplication is also minus 42 upon 15, and here we will say that you will find that the multiplication is a commutative for the rational numbers. Therefore in general, A into B is equals to B into A for any two rational numbers. Next, the division. Here minus 5 by 4 is divided by 3 by 7. Is they are equal? they are not equal. How they are not equal? See this here. 5 by 7 is divided by 3 by 7. See this here. Minus 5 by 7. This will become multiplied and reciprocal. That is a 7 by 3. The 7 get cancelled. You will get minus 5 by 3. Next, 3 by 7. Okay. Divided by minus 5 by 4. And here you will get 3 by 7 into in bracket minus 4 by 5. If we take their multiplication, then you will get minus 12 upon 35. Now again these two are not equal, and therefore so the division is not commutative for the rational numbers. Okay. Now we see this table again. Try this. Complete the following table. Numbers. What are the numbers? Rational numbers, integers, whole number, natural number. Which is the property? Commutative is a property for the addition, subtraction, multiplication and division. Now for the rational numbers, integers, whole numbers and natural numbers, addition is a commutative. It holds for the all these numbers. What about the subtraction? Subtraction is not the commutative for the all numbers. Subtraction is not hold for the all numbers. For the rational numbers, integers, whole number and natural number. Multiplication, that is any two numbers. If we take the rational numbers and their multiplication is a commutative for the all these numbers. Okay. In case of the division, for all these type of the numbers, rational, integers, wholes and natural number, the division is not commutative. Okay. Okay, division is not commutative for the rational number. Division is not commutative for the integers. Division is not commutative for the whole number. Division is not commutative for the natural numbers. Now we'll see the next property, that is associative. Okay. If we take the whole numbers and recall these some operations, that is the operation addition, subtraction, multiplication, division, and we are taking the numbers as a whole number. See this here. That is a 3 plus in bracket 4 plus 5, and you will get here that is a 3 plus 4 plus 5, that is a 9, and here 7 plus 5, both of them addition is a 12 and 12 is equals to 12. Therefore here we say that the addition is associative for the whole number. Okay. Subtraction, that is a 3 minus in bracket 4 minus 5. If we solve this, that is a 3 minus 4 minus 5 means what? You will get minus 1. And what about here? 3 minus 4, you will get minus 1, and here minus 5, that is a minus 6 is not equals to 4, and therefore we'll say that subtraction is not associative for the whole numbers. Okay. Next, multiplication, that is a 7 into in bracket 2 into 5, and that's equals to 7 into 2 into 5. Therefore their multiplication is the same. Therefore we will say that the multiplication is associative for the set of whole numbers. It means that if we take any two numbers, any three numbers, that is a, b, c, and a into in bracket b plus c, that's equals to a into b into c. Okay. Next, the division, that is a 7 upon in bracket 2 by 5, and that is not equals to, this is not equals to 7 upon 2 in bracket divided by 5. Okay, therefore division is not the associative. Next, the integers. What are the operations? Addition, subtraction, multiplication, division. And if we take any two integers, and for example -2, 3 and -4, and the property is a -2 plus in bracket 3 plus -4, and that is equals to -2 plus 3 plus -4. You will get the same number, same addition, and therefore for any two integers a, b, c, a plus in bracket b plus c is equals to a plus b plus c. Therefore we say that the addition is a associative. What about the subtraction? Again here subtraction is also here not associative. Subtraction is not associative for the set of integers. Okay, 5 minus in bracket 7 minus 3. If I will write here 5. What is here? You will get -4. Okay, and what about here? -2, and here -3. 5 minus 4, you will get here 1, and here -5. 1 is not equals to -5. Therefore subtraction is not associative for the set of integers. Multiplication, yes, multiplication is associative. If we take multiplication of first of all -7 into -8 and then multiplied with by 5, and that's equals to 5 into -7 into then -8. Therefore multiplication is associative. Therefore for any three integers a, b, c, a into in bracket b plus c, sorry, b into c, and that's equals to a into b and then into c. Therefore multiplication is associative for the integers. Next, division. Again the division is not the associative. That is a -10 upon 2 is divided by -5, and that's not equals to -10 is divided by in bracket 2 divided by -5. Therefore division is not associative. We can perform this type of the division. Next, here the addition. Again same types of the properties are repeated here. Okay, now from all these we will complete this table. Numbers, rational numbers, integers, whole number, natural numbers. Associative for the addition. All these numbers are associative for the addition. All these type of numbers are associative for the multiplication, and all these type of the numbers, natural number, rational numbers, integers, whole number, natural numbers, these are not associative for the subtraction. And also the divisions are also, we can complete this table. Now the role of 0. Look at the following. That is a 2 plus 0 is equals to 0 plus 2. Then you will get the 2. Addition of 0 to a whole number. -5 plus 0. Okay. -5 plus 0. 0 plus -5, and that's equals to again -5. That is addition of 0 to an integer. Next, -2 by 7 plus 0 is equals to 0 plus -2 by 7, and that's equals to -2 by 7. Addition of 0 to rational number. What we conclude here? We have added this 0 to the whole number, integers and rational number. What do you observe here? You will find that when you add 0 to a whole number, then the sum is again whole number. This happens for the integers and rational numbers also. Therefore, in general, a plus 0 is equals to 0 plus a, that's equals to a, where a is a whole number. B plus 0 is equals to 0 plus b is equals to b, where b is an integer. C plus 0 is equals to 0 plus c is equals to c, where c is a rational number. Okay. Therefore, 0 is called the identity for addition of rational numbers. It is the additive identity for the integers and whole numbers as well. and therefore in general 0 is called the identity for the addition of rational numbers. It is an additive identity for integers and whole numbers as well. Now the role of 1. See this here. 5 into 1 is equals to 5. 1 into 5, that is equals to also 5. Minus 2 by 7 into 1 is equals to 1 into minus 2 by 7, and that's equals to minus 2 by 7. 8 by 3 into 1 is equals to 1 into 3 by 8, and that is equals to 3 by 8. And again here you will find that when you multiply any rational number with 1, you get back the same rational number as the product. You will find that a into 1 is equals to 1 into a, that is equals to a for any rational number, and hence we conclude here. We say that the 1 is a multiplicative identity for rational numbers. Next, the negative of a number. While studying the integers, you have come across some negative of integers. What is the negative of 1? It is a minus 1. Because 1 plus in bracket minus 1 is equals to minus 1 plus 1, and that's equals to 0. So that what will be the negative of minus 1? The negative of minus 1 is 1. Also 2 plus in bracket minus 2 is equals to minus 2 plus 2, that's equals to 0. So we say 2 is a negative of negative or the additive inverse of minus 2 and vice versa. Means what? The additive inverse of minus 2 is plus 2 and additive inverse of plus 2 is a minus 2. And therefore in general, for an integer a, we have a plus in bracket minus a is equals to minus a plus a, that's equals to 0. So a is a negative of minus a and minus a is a negative of a. Therefore for the rational number 2 by 3, we have 2 by 3 plus in bracket minus 2 by 3, then here you will get 0. And also minus 2 by 3 plus 2 by 3, and that's equals to 0. And similarly for all these numbers. And therefore in general, for a rational number a upon b, we have a upon b plus in bracket minus b upon a, that's equals to minus a upon b plus in bracket plus a upon b, and that's equals to 0. Therefore we say that minus a upon b is the additive inverse of a upon b, and a upon b is the additive inverse of minus a upon b. Okay. Now the next topic, reciprocal. By which rational number would you multiply 8 upon 27 to get the product 1? Obviously it is a 21 upon 8. Since the 8 upon 21 into 21 upon 8, that's equals to 1. Similarly, minus 5 by 7 must be multiplied by 7 upon minus 5 so as to get product as 1. We say that 21 upon 8 is a reciprocal of 8 upon 21 and 7 upon minus 5 is a reciprocal of minus 5 by 7. Okay. Now one question is that, can you say what is the reciprocal of 0? That is, a 0 has no reciprocal. Is there a rational number which when multiplied by 0 gives 1? No. That is, any number multiplied with 0, then you will get 0. Therefore 0 has no reciprocal. Okay. Thus the 0 has no reciprocal. We say that a rational number c upon d is called the reciprocal or the multiplicative inverse of another non-zero rational number a upon b if a upon b into c upon d, that's equals to 1. Now the next, distributivity of multiplication over addition for rational numbers. Okay. To understand this, consider the rational numbers minus 3 by 4, 2 by 3 and minus 5 by 6. What is the distributive of multiplicative over the addition? Means what? Minus 3 by 4. This is the multiplication over addition. Therefore, if you solve this bracket, then you will get that is a minus 3 by 4 into, here take the LCM as 6, multiplied here numerator and denominator by 2. Then here you will get 4 plus in bracket minus 5 upon 6. And if you simplify it, minus 3 by 4 into minus 1 by 6, and that's equals to minus that will become plus, and there is you will get 1 upon 8. Okay. And here also minus 3 by 4, that is if you multiply minus 3 by 4 into 2 by 3, then what about their product? Their product is minus 1 upon 2. And if we multiply minus 3 by 4 into minus 5 by 6, their product is a 5 by 8. And if we add it, that is the product of these two is a minus 1 upon 2, and product of these two is a 5 by 8. And if we add it, then you will get 1 upon 8. And here, if we simplify this bracket and multiplied with minus 3 by 4, you are getting 1 upon 8. And if we simplify this bracket, it means minus 3 by 4 into 2 by 3 plus minus 3 by 4 into minus 5 by 6. Again, you are getting 1 by 8. And therefore, we say that here minus 3 by 4 into, in bracket, 2 by 3 plus minus 5 by 6, and that's equals to minus 3 by 4 into 2 by 3 plus, in next bracket, minus 3 by 4 into minus 5 by 6. Therefore, distributivity of the multiplication over addition and the subtraction. Okay. Now see this here for all the rational numbers a, b and c. A in bracket b plus c, that's equals to ab plus ac. A in bracket b minus c, and that's equals to ab minus ac. And therefore we will say that the distributive of the multiplication over addition and the subtraction, it holds. Now we'll start the exercise 1.1. Use appropriate properties and the find minus 2 by 3 into 3 by 5 plus 5 by 2 minus 3 by 5 into 1 by 6. Okay. Now see this here. We will write here first example, minus 2 by 3 into 3 by 5 plus 5 by 2 minus 3 by 5 into 1 by 6. Keep this as it is, and see this here. We are using here using the commutativity of the rational numbers. Means what? We are writing here the first term and then 5 by 2 is here. Okay. See this here. 3 by 5 is a common for these two terms. Okay, minus 3 by 5. We are taking minus 3 by 5 as a common. Then in bracket you will get 2 by 3. We are taking the minus sign as a common. Therefore this sign will, minus will become plus here. If we take minus 3 by 5, then here you will get 2 by 3 plus 1 by 6, and keep 5 by 2 as it is. Okay. Next, minus 3 by 5 and simplify this. That is, or you can make here base 3 multiplied n and d by 2. Then you will get 2 into 2 plus 1 upon 2 into 3, that is a 6. Both of them have the same base. Therefore, 2 into 2 plus 1 upon 6. And again simplify 2 into 2, 4 plus 1. You will get 5 upon 6 minus 3 by 5 plus 5 by 2. Again here this 5 will get cancelled. You will get minus 3 by 6. Okay, 5 will get cancelled. You will get minus 3 by 6 plus 5 by 2. Again the simplification. Multiplied here numerator and denominator by 3. Then you will get here 6 and here 15. Minus 3 plus 5 into 3 upon 6. And overall minus 3 plus 15 upon 6. And here you will get 12 upon 6. If we divide it, then you will get 2. And overall, if we simplify here this, you will get the answer as a 2. Okay. Next, 2 by 5 into, in bracket, minus 3 by 7 minus 1 by 6 into 3 by 2 plus 1 upon 14 into 3 by 5. Now see this expression. Here we have the 2 by 5 and 2 by 5. And that's why here we'll apply here the first commutative property. That is a 2 by 5 into minus 3 by 7. Okay. We'll take this term as a first here plus 1 by 14 into 2 by 5 and then this term is here. Okay. That is a minus 1 by 6 into 3 by 2 by using the commutativity. Next 2 by 5. We'll take the 2 by 5 as a common from these two. Take 2 by 5 as a common into in bracket minus 3 by 7 plus 1 upon 14. And what's remaining here? The remaining is a minus 1 by 4. How it is a minus 1 by 4? Take here, simplify this here. You will get here 2. 2 into 2, 4. That is for the numerator you will get 1 and to the denominator you will get 4 and therefore overall you will get here minus 1 by 4. Again the simplification here. Multiplied here numerator and denominator by 2. Then to the denominator you will get 14. That is a minus 3 into 2 plus 1 upon 14. Therefore 2 by 5 into minus 6 plus 1. You will get minus 5 upon 14 and lastly minus 1 by 4. Again the simplification. Here this 5 and 5 will get cancelled. 2 1s and 2 7s are 14. Here you will get minus 1 upon 7 and minus 1 by 4. Again make here cross multiplication. 1 into 4 minus 4. 7 into 1 minus 7. Minus 4 minus 7 minus 11. Therefore you will get minus 11 upon 28. Okay. Their multiplication. To the denominator here we have the 7 into 4 that is a 28. Okay. Therefore the answer is minus 11 upon 28. Now the next. Write the additive inverse of each of the following. Additive inverse means what? Which element we should add 2 by it, then and then you will get 0. Therefore, for in general, for a rational number a upon b, we have a upon b plus in bracket minus a upon b or minus a upon b plus a upon b, you will get 0. Therefore, we will say that minus a upon b is the additive inverse of a upon b and a upon b is the additive inverse of minus a upon b. And therefore, it's clear that here the additive inverse of 2 by 8 is a minus 2 by 8. Next, additive inverse of minus 5 by 9 is a 5 by 9. Additive inverse of this minus 6 upon minus 5. Here the division of minus upon minus, that will become plus. That is a minus 6 upon minus 5, that is a 6 by 5. Therefore, additive inverse of 6 by 5 is a minus 6 by 5. Next, 2 by minus 9. Now the 2 by minus 9 is nothing but minus 2 by 9. Therefore, additive inverse of minus 2 by 9 is a 2 by 9. Next, 19 upon minus 6. 19 upon minus 6, that is equals to minus 19 upon 6. Therefore, additive inverse of minus 19 upon 6 is 19 upon 6. Now next here, verify that minus of minus x, that's equals to x. Okay, now the first, x is equals to 11 upon 15. If we take x is equals to 11 upon 15, then what about it's a minus x? Here we change the sign. Minus x is equals to minus 11 upon 15. And if we add it, then you will get 0. Okay, the same equality of the 11 plus in bracket minus 11 upon 15, that's equals to 0. And they show that the additive inverse of minus 11 upon 15 is 11 upon 15. That is a minus of minus x and that is equals to x. Now the next, x is equals to minus 13 upon 17. Again the additive inverse of x is equals to minus 13 upon 17 is minus of this. Now the minus x, we can write here minus x is equals to minus in bracket 13 upon 17, and overall here you will get plus 13 upon 17, and therefore here you will get 13 upon 17, and since minus 13 upon 17 plus 13 upon 17, and that's equals to 0. Okay, and therefore here this shows that the additive inverse of minus 13 upon 17 is a 13 upon 17, that is a minus of minus x, and that's equals to x. Next, this is very simple. Find the multiplicative inverse of the following: minus 13. Now we know that here we say that the rational number, if we have the rational number c upon d, is called the reciprocal or the multiplicative inverse of any non-zero rational a upon b if a upon b into c upon d, and that's equals to 1. Now we have the rational number minus 13, then its multiplicative inverse is minus 1 upon 13. We multiplied minus 13 into, in bracket, minus 1 upon 13, and here you will get 1. This 13 get cancelled. Okay. Next is minus 13 upon 19. Again its multiplicative inverse is minus 19 upon 13. Next, the multiplicative inverse of 1 by 5 is a 5. Multiplicative inverse of minus 5 by 8 into minus 3 by 7. Now here we will simplify here. Minus minus, that multiplication will become plus. 5 into 3, 15. 8 into 7, 56. Therefore, the multiplicative inverse of 15 upon 56 is 56 upon 15. Next, minus 1 into minus 2 by 5. It's a multiplicative inverse. Now, first of all, we will make this product. That is minus 1 into minus 2 by 5. Minus minus, that will become plus. That is a 2 by 5. Therefore, the multiplicative inverse of 2 by 5 is a 5 by 2. Next, minus 1. Again, the multiplicative inverse of minus 1 is again minus 1. That is minus 1 into, in bracket, minus 1, you will get it's a plus 1. Okay, therefore the multiplicative inverse of minus 1 is a minus 1. Now the next, name the property under multiplication used in each of the following. What is your minus 4 by 5 into 1 is equals to 1 into minus 4 by 5, and that is equals to minus 4 by 5. 1 is a multiplicative identity here. Okay. Next, minus 13 upon 17 into minus 2 by 7. Okay. That's equals to minus 2 by 7 into minus 13 upon 17. It's a commutative. Next, minus 19 upon 29 into 29 upon minus 19, and that's equals to 1. It is called the multiplicative inverse. Now next question, multiplied 6 by 13 by the reciprocal of minus 7 upon 16. Okay. Now here the multiplied 6 by 13 by the reciprocal of minus 7 upon 16. The reciprocal of minus 7 upon 16 is minus 16 upon 7, and therefore here we have 6 upon 13 into minus 16 upon 7. Here we have the bracket. Okay, and their multiplication is 6 into 16, 96. 13 into 7 is 91. Okay. Now the next, tell what property allows you to compute 1 by 3 into 6 into 4 by 3 as 1 by 3 into 6 into 4 by 3. We observe that the multiplication is associative for rational numbers. That is, for any three rational numbers a, b and c, a into, in bracket, b plus c is equals to, in bracket, a into b then into c. Okay, and this property is nothing but the associativity. Okay. Next is 8 upon 9 is a multiplicative inverse of minus 1 and 1 by 8, why or why not? It is not the multiplicative inverse. Why? How it is? If it is a multiplicative inverse, then their product should be 1. However, here the product is not 1. That is 8 upon 9. If we simplify this, minus 1 and 1 by 8, that is 8 into minus 1, it's a minus 8. Minus 8 and here is a 1. That is a 9. 8 into 1 is 8. 8 plus 1, 9. It's a minus 9 by 8. And if we multiply here, this 9 and 9 get cancelled, 8 and 8 get cancelled, you will get minus 1, which is not equals to 1. And therefore, it is not the 8 upon 9 is not a multiplicative inverse of minus 1 and 1 by 8. Okay. Next, is the 0.3 is a multiplicative inverse of 3 and 1 by 3. Why or why not? It is a multiplicative inverse. Now how it is? Now 3 and 1 by 3 can be written as 3 into 3, 9 plus 1, that is a 10 by 3. Now 0.3 into 3 and 1 by 3, that's equals to 0.3 into 10 by 3. And what about the 0.3? 0.3 means what? 3 by 10. This 10 and 10 get cancelled, 3 and 3 get cancelled, you will get here 1. Here the product is 1 and hence 0.3 is multiplicative inverse of 3 and 1 by 3. Now the next. Right. The rational numbers does not have a reciprocal. Okay. Which rational number? It means that which rational number do not have the reciprocal. 0 is the rational number, but its a reciprocal is not defined. Next, the rational number that are equal to their reciprocal. Okay, the reciprocal of 1 is 1, reciprocal of minus 1 is also minus 1, and therefore 1 and minus 1 are rational numbers that are equal to their reciprocal. That is 1 into 1, 1 into 1 upon 1, that is equals to 1, minus 1 into minus 1 upon 1, that is equals to also 1, and therefore 1 and minus 1 are reciprocals. 1 and minus 1 are the rational numbers that are equal to their reciprocals. Next, the rational number that is equals to it's a negative. 0 is the rational number that is equals to it's a negative. That is a 0. And what about the minus of 0? And that is equals to 0. Therefore, the rational number that is equals to it's a negative is a 0. Next, fill in the blanks. Okay, see this here. Question number 11. 0 has dash dash reciprocal. 0 has no reciprocal. The numbers and their reciprocal and their own reciprocals, that is a 1 and the minus 1 are their own reciprocals. The reciprocal of minus 5 is minus 1 by 5. Reciprocal of 1 upon x, where x is not equals to 0, is x. The product of two rational number is always a rational number. Reciprocal of a positive rational number is positive rational numbers. And in this way, we have completed the exercise 1.1 from the first chapter. Now we'll see in the next video. Till then, goodbye.